Linear drive motors versus ball screw. Give me your take on the two and the differences.
Well, as you can see on this demo, where Chiron have been very, very big in the turbocharger market, is obviously producing impellers. So they've got some very, very big coverage worldwide making those particular components. Where the enhancements have been made is that as these impellers are moving up in speed to 300,000 RPM, surface finish quality is absolutely key, and to the balancing of those particular components as well. And where you have a dedicated impeller where you're making very, very small movements on a ball screw, there is potential wear patterns that are going to come into that which could affect the surface finish and quality, but the linear motor, we don't have to worry about that, and it gives us fantastic repetition.
So is this new to Chiron?
Absolutely, this is now being launched as of today from this open house. Chiron, as they do with all of their research and development, as they're putting a program together, will actually beta test that at one of their biggest customers in this particular field in the market, and the results that have come back from that have been absolutely fantastic, with roughly around about a 30% productivity gain over the existing ball screw machines they're using.
That's a lot. I can see what you mean with the ball screw here, or the ball screw element, having to do a lot of movements very quickly. Over a period of time there could be wear in that, but with linear drive motors there is none, is there?
Absolutely not. That's exactly why we're moving there, and that's why a lot of people have come to be able to see the launch of this machine, because it's now available for sale.
What about the cost of actually running a machine with a linear drive motor compared to a ball screw? Is it a bit more costly?
Yeah, I mean, looking at some of the figures that Chiron did, they're very big on cost of ownership. So when they're actually looking at all of this, they're actually looking at what the potential running costs of that could be. Linear motors do actually draw a little bit more power, but certainly with the drives and the low energy drives that Siemens have been developing as well with them, it's actually taken that back. So where you could have probably looked at about 10% extra power requirement, they've probably brought that back to about 2 or 3%, which for the gains that this is going to give over its lifetime, it's probably quite a small amount.
I also think there's another argument with this about the control element, because you can have a machine that is very, very fast acceleration, rapids and all the rest of it, but this control has got to process all that to get the finished part, hasn't it?
Absolutely, and I think where we've got a series of controls that Chiron offer here, which is obviously Siemens 840D, Fanuc 31i B5, and then Heidenheim TNC 630. But we tend to find that on this type of project, the Siemens tends to run around about 10 to 15% faster. So they've really done a lot of development on that drive system and the control processing speeds to meet up with the demand of this machine technically.
So control can keep up with the speed?
Absolutely.
And it has to.